fully with I'm not all the in the game. Let's just say fully, but I'm here. So what did we do? You didn't have homework. Oh, good. Thank goodness. I was trying to think, what did you have for homework? And oh yeah, you didn't have homework. Oh, but I've got a quiz anyway. So let's go ahead and do the quiz. Now, let's just now. I should warn you or tell you about the quiz. I normally the day before an exam, I don't collect the quiz. But because this week I don't know if I'm probably gonna be here tomorrow. But I don't know if I'll be here on Wednesday or Friday. I thought I can't collect the quizzes, so we'll do it the way I normally do the quiz before the exam. Is you try it, we'll go over it, and I'm going to trust that you, while I'm going over it, are fixing your mistakes so that you have 100. So at the end, I'll ask, does everyone have 100? And if anyone doesn't, let me know. And as long as no one wants a grade less than 100, I'll just put 100 in for everyone. But I'd like you to try it because this is good practice for the exam. So I guess it's up on the screen already, but I'll give you the piece of paper. Yours is not yellow. Sorry, I didn't print it in color. There it is. There's two. There you are. Here you go. 1, 2, 3. 1, 2, 3, 4. Uh-oh. Do I have enough? I think I do. Thank you so much. There you go. Enjoy. There's probably an extra. I'll take it. All right, if you have extras, you can keep them if you want as a souvenir. Oh, I see people have quizzes in front of them. Was that the homework? Oh, to do this quiz. It's okay, it's okay. I'm not collecting it because I can't deal with that this week. Interesting. I guess I have to go over this, don't I? Yeah, hang on to it. We'll go over that as well. Okay, but this one. So quiz 6 and apparently quiz 7. It's out of order. It's fine. I just thought this would be good practice to have another go at this stuff. So take a few minutes. I'll try to get myself sorted out here. Hmm. Boy. Yes. Oh, yeah, sorry, I changed, it's around the line x equals 5, the way that the diagram shows it. My apologies, I guess I edited this morning and yeah, I didn't change, I'll change it up here. Thank you for, yeah, this is the one like the diagram. So, yeah, it's do I have something else written somewhere? No, I do? Oh, I didn't edit. Oh, I see. Some of you have the wrong functions. What in the world? Okay, let's hear. I'll fix. Like my apologies. Uh, yeah. Okay. Some of you have a semi-defective quiz. Okay. Good. Good thing this isn't official. So some of you have a semi-defective quiz. Some of you have a super defective quiz. So here's the correct version. Here is it should be y equals x squared. You have the right diagram though, all of you. That's what fooled me is I forgot to edit the whole document. And then this is the line y equals 4, and we're rotating around the line x equals 5. you know, making your little, you'll have a thing. I'll bring it out. I've got the solid that this would look like. So you'll have to change the around the line y x equals 5 is in each of these cases. So this is what it should look like. That, I believe, is the corrected version. So my apologies. We will try to move on. Oh, I left it. No. So because I'm not collecting this quiz, I don't mind giving you less time than you need. So in about maybe a minute, we'll start going over it, but don't fret. If you're not fully done with that final integral, we're going to go over this together. All right, let's give it a go here. Let's see how you're doing now that you have the corrected version of the quiz, hopefully. And so the first, here, let me scroll over so you don't see the final, well, I don't have the final answer, but let me just draw this on here, a blank version, then I'll go over, because I've got it set up. I didn't finish it myself, just so you know, I thought we could finish it together. But the first step is you're going to put a rectangle somewhere. Somewhere, I don't care where you put it. It's going to be a vertical rectangle. So it can be either to the left or the right. I'll put it over here on this one just to show you. You put it anywhere you'd like, as long as it's somewhere in this yellow region. And I always like to label the small side of my rectangle so that I know, this is going to be, everything's going to be about x. X is the special variable. Delta x is the little piece. So that was part A. That's all you had to do. You do that, you got 25% of the problem right. Look at that, 25% so far. Next, write down the formula for the volume of the solid. So we're going to have a volume formula here. Well, to do that, I had to remind myself, what is this going to look like? This is going to look something like this, and I'll explain in just a minute. But you're going to have this shell, and you can ignore the letters for just a minute. And the thickness of the shell is delta x. And I remember that the volume of this shell is going to be 2 pi times the radius, how far out it is, times the height, times delta x. So we have to keep these things sorted out. With the discs and washers, it was pi r squared times the height. And with the shell, it's 2 pi r h times the delta x. So just, keeping those things straight is going to be a problem. And honestly, some of you will probably use the wrong formula on the test for, the different things. And the only thing I can suggest when you're taking the test is to just be careful, to think through what is going to be the shape of the thing that results from rotating this rectangle around the axis over here. So you take that rectangle, if you rotate this thing around, you're going to get a giant tube is what it's going to look like. Whereas if we rotated that around this axis, you would have a big disc or a washer. Okay, so getting back to the problem. So I wrote this in here. I need to, so you can see, you could put the rectangle anywhere you like. It really doesn't matter. So let's talk about the height first. We'll get over there to the radius. The height is pretty easy. It's going to be the top minus the bottom, right? Top minus bottom. In this case, I tried to make it as easy as possible. And so I used 4 and x squared. So this will be 4 minus x squared is the height. Sorry, I don't have any more room over there, so it's kind of crammed. The radius, how far are we? So essentially, I want to know, how far are you from the axis of rotation? So that rectangle, how far is it? Well, check it out. It is 5 plus this much. So 5 plus whatever this is. Well, this is x. But x is a negative number back here. And so that's why I have 5 minus x, because let's say that this is at -1, just for the sake of argument. Suppose that this here is -1 unit to the left, then this would be 6 units, would it not? From there to there is 6, and so 5 minus -1 is 6. On the other hand, if you have drawn your rectangle here, it's a little bit more obvious that this distance is 5 minus x. It still is 5 minus x because the whole distance is 5, and this little distance here is x, so 5 minus x. So that's what the radius is. Now let's put it all together. Let's get this formula, the formula that you should have put in this little gap here, which is hardly big enough for anything. 2 pi times 5 minus x times 4 minus x squared times delta x. So that's what you should have there. And I want to point something out that I think is a misconception about mathematics. And it's a misconception that we, as mathematicians, oftentimes we perpetrate. We make this more, people to have this misconception by the way we do things. If you read a math text, you will see sometimes a problem like this with no work. They just say the formula for the volume of the solid is, and they put this down as if it came out of nowhere, or that you should be able to figure this out without doing any other work. That's not the way math works. It's just the way we write math. Like when I wrote papers back in grad school, I don't do this anymore because I don't have time to do math research, but I would write and I would just say, here's this formula, and I don't tell where it came from. You know, people can check my work if they want to, but I'm not going to show my work to the mathematical community. Well, I mean, I show some of it, but anyway, so it just seems like it magically appears. You have to sort it out yourself, but that's the sorting. So don't feel like you should be able to just write this down out of nothing. So it should, there's a lot of work that, because looking at this, how would I, that just is so complicated. So the only way I can understand that is through drawing pictures and taking these notes. That's the way to do it. Okay, so any questions about part B? Yeah, what do you think, Hayden? Nope. Yeah, so that's another common mistake. Thank you for taking one for the team. So here, let's do the contrast really quick. So if you have a disk or a washer, then here's the typical thing you're going to have is you'll have the volume is pi r squared times delta x. So you'll usually have like pi times some function squared times the delta x or delta y. And then if you have a shell, so the shells, here's what they look like, 2 pi rh delta x. Now, one way to think of this, to make sure you keep it straight, that there is no square over here, is if you think dimensionally, if we're measuring things in, say, centimeters, volume is cubic centimeters. So let's go through and see what we're measuring. R is measured in centimeters. So you have 2 centimeters there, two centimeters squared, if you will. And then delta x is a length, that's centimeters. So you have 3 lengths multiplied together gives you cubic centimeters. Over here, I have 3 lengths multiplied together. There's this one, and that one, cubic centimeters, if these are centimeters. So yeah, if I made one of these squared, then you'd have 4. So we'd be in the 4th dimension. We don't want to go there. All right, anything else? No, this is a good question. Thank you, because that's the sort of thing that some students will make mistakes on Friday, and it's hard for me to remember all the different mistakes. So thank you. Yes, Hayden, another one? Okay, well, let me defer, but that's a good question. So we need to, let's do that before we get to our averages. We will talk about how to tell the difference between a washer and a shell. Anything else about the formula? Now we got, so remember, your job now is to, if you don't have this formula, correct yours. That way I can honestly say, when I'm confronted by my boss, that everyone did get 100 on this quiz eventually. Actually, my boss isn't going to confront me. Okay, let's do this. Now the integral. If you have that volume over there, that pink volume, the integral is super easy because you just turn that into an integral and turn the delta x into dx. So let's do this. I'm going to put the 2 pi out front just for fun. And then this is going to be 5 minus x and 4 minus x squared. But there is one thing lacking, isn't there? And that is the limits. We need limits for this to be the true integral. And so I need to know, where do I start? Where do I finish? So we're talking about the x values. I think you can probably guess, just looking at the diagram, what the left and right endpoints are. But we're going to do it the right way. It won't take long. So I'll do it over here. I want to know, where is x squared equal to 4? Okay, I think you probably know, but let's, x squared minus 4 equals 0. X plus 2, x minus 2. Yeah, that was probably overkill, wasn't it? So it's 2 and negative 2. Those are the limits. All right, now we're all happy. We got the integral. Whew. One more step, and this is nice and easy because this is an easy integral. I've got to get rid of my thing here. And then don't worry, we'll remember to deal with the difference. Okay, so let's do this compute. In order to do this, I'm going to have to multiply. Yeah, another common mistake is to just do the integral of this, multiply it by the integral of this. You know that's not right, I hope. We've got to multiply first. So we've got 20 I'm using FOIL. First, I'll do FEOL, actually. First inner, because I don't like to have things out of order. Outer, and last. There it is. So you use FOIL if you want. I did the opposite, but it's all the same. Anyway, there's my my trinomial, or it's a cubic, isn't it? But yeah, it's the product of those two binomials. And I have my -2 and 2, 2 pi evaluated. We'll do 20x minus 2x squared minus 5x cubed over 3 plus x to the 4th over 4, evaluated from -2 to 2. And then, of course, the rest of this is just plugging and chugging. So I'm not going to belabor this too much. Let's see if I can just do it really quick. Let's see. 24, just a sec. 80, and that's going to be 40 thirds, 80 thirds. Okay, so I'm getting 80 minus 80 thirds, and that's after simplifying. So hopefully that's right. I don't know if anyone wants to. Oh, I know, I can check it. I can check it on the computer. But here, I'll just get a quick answer really quick, and then we can check. See if my mental, I've been challenging my mental calculator today to see if I can do mental arithmetic and so forth. So this will be a good check to see if my brain has started to go to mush. So give me a sec. So we have, I'm just doing this basically on my calculator. Integral of, it'll just take me a minute to type this in. You know what, I should start with the original. There, I'll do that. So you could go to like Desmos or whatever it is that you like, your favorite online calculator. Make sure I've got this typed correctly. Okay, x equals -2 to 2. And yeah, okay, just a minute, just a sec. 80 thirds. Yes, I got it right. Sorry, it gave me the answer in as 160 thirds times 2 pi, you know, because it combined the 80 and the 80 thirds. So, which I guess I should have. Oh yeah, there it is. There's the 160 thirds. Yeah, this is correct. Yeah, that's going to be a total of 320. I guess I didn't scroll. There, very nice. So give me a smiley face because I got my mental arithmetic right. All right, so is everyone happy with that? By the way, on the test, you might be saying, "Oh, do I have to do mental arithmetic?" No, you don't. You just do your calculator. I don't know what, here, I do know. Oh, come on. Oh, sorry. I typed this. So apparently I should just trust my brain and not my, there we go, 335.1. So yeah, whatever, that's fine. You don't have to get all fancy on me. I love this. This makes me happy, but this is fine. Okay, let's deal with, well, first of all, check other questions about this before we talk about Hayden's question, which is a good one. Okay, let's deal with Hayden's question. How do we know the difference between a washer and a disc? So here, I'll give you a couple of hints, and I'll show you a couple of examples. So let me just erase some of this stuff up here. Just a minute, I'm just going to erase this. Trying. Can I delete that? Delete. There we go. And I'm just going to duplicate, in a sec, this picture will be helpful to have elsewhere. So I can draw on it. Copy. Okay, bear with me down here. Okay, so let's do that, and let's do that. Okay, so difference between discs and or washers and shells. So here's the main difference, the easy way to figure it out is if you draw your rectangle, and if your rectangle, it's a tall, skinny rectangle, is it not? It should have a skinny side and a tall side. If that tall, skinny rectangle, if it is parallel to the axis, like this picture. Here's what I mean by that. Notice that here's the rectangle, here's the axis. They're going the same direction, are they not? So if it is parallel with the axis, then you're going to use shells. So this is sort of I know that this is, some of you like to have things, rules to memorize. And so here's the rule. If you have a tall, skinny rectangle that is parallel with your axis, you're going to use a shell. On the other hand, and here's another picture and I know that this is not the best way to do this particular problem, but if I drew my rectangle like this with delta y, notice that if the rectangle is perpendicular to the axis, then you're going to use washers or discs, however you want to call it. So, and then the way that I prefer, so this is the rule that you'll find in many textbooks. They'll actually have this. It's like, here, memorize this. I much prefer just thinking about what shape I get when I rotate this thing around. And the key here is to draw your rectangle to be tall and skinny. If you have a tall, skinny rectangle, then it should be obvious that in this first case, you're going to end up with something that looks like a toilet paper tube. Tall and skinny, rotating around that axis, you get this tube. And hopefully, if you've drawn this as long and skinny, when you get done rotating, you're going to end up with something that looks very different. It's going to look like a washer or a donut, a long, skinny donut. There, is that good enough? Why not? So here, this one is a shell. This one is a washer. There's the difference. Hopefully that helps you, Hayden, and anyone else. Other issues or questions before we talk about averages? All right, let's do it. Averages. So sorry, I forgot to ask. Did everyone get 100%? Did anyone not get 100% after we've got it all corrected? You've got it. Does everyone currently have 100%? Okay, yeah, you don't have to hand it in. This is, eventually we'll do this. Let's see, does this work? Let's see. Yeah, it's upside down. I got to remember to do it this way. Okay, so there. So check. And then I also have this one. Thumbs up. So if you really need the stamp, I'll put these over there. You can stamp your own on the way out. So if it'll make you feel better. There you go. So you can either have the red one. Let me double check so that I know which orientation we need to have these. I believe, yeah, the writing has to be away from you for it to be oriented properly. So I'll put them down the way they should be oriented. You can put your paper here, stamp away, make yourself happy. You can have both a thumbs up and a check mark if you'd like, kind of like what I did right here. Okay, so we're going to do averages today. Oh, no, we have this other quiz. Okay, let's whip through this. I want to get the averages. Yeah, let's get this done. This is quick. So this is the one that I gave you, and I said, do this for homework for Monday. At that time, I knew my life is, getting jumbled a little bit. God's shaking it up. Like, here you go. Have fun, which is fine. I mean, this is otherwise, life would be boring, wouldn't it? We have this 2-meter long rope, has a mass of 10 kilograms coiled on the ground. And so the density, let's do this really quick. Density of the rope is 10/2 or 5 kilograms per meter. So kg per meter. And we're going to lift up the rope to a height of 2 meters. In other words, here's what sort of a picture looks like in between, if you will. So let's see. Can I draw? I probably can't. My cartoon is going to look really dumb. There is there you go. My hand holding on to the end of the rope. And no, not too bad, is it? Okay, so I'm picking up the rope. Yeah, I should probably have my fingers touching, shouldn't I? There. Anyway, so that's where I am. I probably would be holding it more, with my fist, but because this is a pretty heavy rope. But here's the important thing, is that at this moment in time, there is X. X units, or X is the length of the rope that is above the ground. That's the length of the rope that I'm supporting. So that will help me figure out the force, which is going to help me figure out the work. Okay, so that's what's going to happen. And just so you know, what we're going to do is we're going to, let's see, can I do this? I'll bet I can. Hold on. Let's see. Group. This will be fun if this works. Okay. Oh, does that work? No, no. Darn. The whole rope got contained. Let me try one more time and then I'll give up. And then try grouping that. I should have drawn the, oh, that's much better. Okay, so here's what's happening is there's the hand. We're going to move the hand up. Oh, and then the fingers broke. Oh, it was such a heavy rope. But anyway, you get the picture. Is we're moving. Here, I'll just do it a little bit. Then the fingers just get stretched. But that little tiny bit, that's how far we're going to stretch this. We're going to move it. So that's delta x is how far. Delta x is how far we're going to move it, each increment. So we're going to move a little bit at a time. And then we're going to add up all of the work done in those little increments. So work is equal to force times distance. The distance that we're moving is delta x. The force, this is going to be a little bit more difficult. We need to do mass times acceleration. And this is not stated. It's not, on this quiz, I don't have a reminder about the acceleration due to gravity. And so if you didn't account for the acceleration due to gravity, I understand. On the test, I think I have all of that information to remind you that you have to account for gravity. But so in this case, the mass of this portion of the rope, the mass is equal to x times the density. So x is how long you have it. It's x meters long. This is the density per meter. So if this is 1 meter, that would be 5 kilograms. If it was half a meter, you would have 2.5 kilograms and so on. So that's the mass. Acceleration due to gravity, we all know, is 9.81. Okay, we'll use 9.8 meters per second squared. So A is approximately 9.8 meters per second squared. And then we get the force is equal to 5x times 9.8. And that's in newtons. So yeah, whatever. And so let's put it all together now. So the work done will be 5x times 9, that's 4.49. Isn't that right? 9.8 times 5 is 49. 49x, that's the force times the distance, and that's the work. In this one increment, when the fingers got broken, that was the work done. Now we're going to integrate this over the entire sort of the motion that you're making. You're going from 0, that is the rope is all coiled on the ground, and you go up to 2 meters, which is about here. So that's the motion that we're doing. So we're going to integrate over that entire stretch. 49x dx. So easy. 49 halves x squared evaluated from x equals 0 to 2, and that is 98 joules is the correct unit. So 98, is that what we got? Did anyone get 98? Oh, it's okay. You don't have to admit. Some of you got it. Okay, good. And some of you were like, did we have to do this? Yeah. So sorry, didn't make it clear. But there it is. So that's it. And there will be a work problem or two on the test on Friday. There is the practice test. I don't know if I don't think I have the answers yet, but I'll be making those before Wednesday. That's basically what we're doing for class Wednesday. So if I'm not here Wednesday, what I'll be doing is I'll be in the hospital making up those answers so that you can look at them. So not to worry, you will have access to those eventually. Onward, we have to deal with averages. So you might say, well, what kind of average do we do in calculus? I thought that was statistics, and indeed it is. And so let's go back to some statistics that I did today. Where is it? There it is. So here, this is actually from today's lesson in statistics. I'm going to erase some of this though. The only thing that really matters is this one. Just a minute, erase. There, we'll get rid of this. So the average, the mean is the thing that we care about. And that you know, because you've probably either had statistics, or if you haven't had statistics, you were in 7th grade once, unless you skipped 7th grade. And in 7th grade, they taught you how to do an average, didn't they? A mean. So this is what it is. You add up, sorry, it's such a mess, Add up the numbers, divide by the number of numbers, right? Add up the numbers, divide by the number of numbers. That's the idea with an average. We're going to do the same thing, though. What we're going to be interested in is the average value of a function. So do I have a diagram? I do not. I just have boring stuff here. So let me get a diagram, and then we'll go back to the boring stuff. So here, we'll put the diagram down here. Sorry, that's all my stats from today. So here's the boring diagram. That is the function y equals x squared. And this is the point 3. Here's 2, and here's 1. So here is the question that we are trying to answer today, and that is, what is the average value of this function over that range? What's the average? So if we used the statistics idea, we would add up a bunch of numbers and divide by the number of numbers. Let's actually go do that. Let's add up these numbers, and this is going to maybe feel somewhat familiar. Let's add up those numbers. How about? So let's see, the 1, when I plug 1 into this function, I get 1. When I plug 2 into that function, I get 4. And when I plug 3 into that function, I get 9. I can add those up. I get 14. And so the average of those 3 numbers is 14/3. Well, that's an approximation of the average. We could do better than that. And I bet you know, and maybe have a little bit of dread about what's coming. But you know what we could do? We could take more sample points. Wouldn't that be fun? So we could do this. Now what I have is I have 6 numbers. I could add up those 6 numbers and divide by 6. I could refine this further, couldn't I? You just keep shrinking and making the rectangle smaller and smaller. Hayden. That's exactly what's going to happen, is we will have a limit. So let me just express in terms of this. I have it in my PowerPoint, but it's just a boring formula. Let me express what this thing is that we're going to do the limit for. So notice that we have a delta x here. See, the delta x is the size of my rectangles. So I purposely made these rectangles because it's something we're familiar with. We've done this when we're doing shells, washers, work. We're cutting things up into small pieces and adding them up. So the formula for an average is you add together all of the function values, and then you divide by the number of function values, right? That's what we do. I mean, we did that right here, didn't we? You just averaged those 3 together. Now, here's the thing about this in. Instead of using in is 6, isn't it? 6 numbers between 3 that were these 6 rectangles. Instead of calling this in, what I'm going to do is I'm going to say in is related to delta x. Does anyone see the relationship between that relates 6 to what this delta x is? I know Hayden does. You know what, Michael, you know? It is not, but it's related to delta x. So it's, yeah, there is a relationship though, and you sense that, don't you? So anyone else? All right, Hayden, I know you're dying. What is it? So there's, okay, so this number you're talking about. Is that what you mean? Oh, okay. So in, okay, so let's, yeah, so Daniel, I want to hear your answer in just a second. I'm going to write down what Hayden just said. You have in times delta x is an important expression for this. Daniel, did you have something to add? Okay, yeah, so Hayden's expression actually tells us how far you're going from left to right. So if you take delta x, this is 1/2, is it not? And if we have 6 rectangles times 1/2 tells you how far you've gone. And so what we're actually going to do is we're going to solve that for in, and we'll get exactly what Daniel said, and that is that in is equal to how far you've gone. And the way I'm going to write this here is this. 3 minus 0 divided by delta x. So you have this gap here. And the reason why I'm going to write it as 3 minus 0 is because you can imagine we might want to find the average for a different interval. And if it's a different interval, you'll use the other, the different range there. So you've got the range of values divided by how big the gap is, tells you how many. Let me fold this into my formula here. And I'm going to have to move this. There we go. And then we'll go back to the boring stuff. But it's much more fun for me to draw. Okay, so in terms of this formula, this will equal the sum of f of x all over, you know what? I'm going to write it like this, just a minute. B minus a over delta x. Here's a, and here's b. Just so that when we get to other problems, we can more easily apply this. So it's just how far have you gone, b minus a over delta x? How big is the rectangle? So that's what I'm going to put down there for now, and we'll convert it in just a sec. So b minus a over delta x. We're so close. So the last thing to note is that we can flip this, right? It's in the denominator. Flip and multiply. You know the rules of arithmetic, fractions. So let's flip and multiply. And this becomes this. The sum of f of x delta x all over b minus a. And just pause there and just see if there are any questions about where that came from. We almost have the formula. We got it. You can probably tell what the formula is going to be. Now we're going to do what Hayden suggested originally and say we're going to do a limit, right? We're going to do a limit. Let's shrink that delta x until it's 0, and that limit becomes the integral from a to b of f of x dx all over the size of the interval. Amazing. Amazing. I just want to thank you because you have tolerated a proof. This is a proof of the formula. Yeah, I could just boringly say, here's the formula, but it gives me so much joy. This is what we do as mathematicians. We love to figure out where the formula comes from. And I realize that some of you don't care, but I just got to tell you, I'm filled with joy at this moment. Okay, so for this problem, and then we'll get back to the PowerPoint. For this problem, we're going to do this. It's the integral from 0 to 3 of x squared dx divided by 3 minus 0. That's it. That's it. It's so easy. So in this case, it'll be 1/3 times x cubed over 3 evaluated from 0 to 3, which is 3. And that's it. That's the average. If you were to take this curve, x squared, between 0 and 3, you want to know what is the average height? It's 3. So half of the values will be above 3, half of them will be below 3. So it's just interesting. Or is that right? No, that is not right. That would be the median. I'm sorry, I misspoke. Got a little bit ahead of myself. Yeah, so, but the average, add them all up, divide by the number, you'll get 3. And I think 14 thirds? 14 thirds is 4 2/3. So if you were to do this again and again, refine this further and further, you would find that average would keep getting down until you got to 3. Okay, now we can go to PowerPoint, the boring stuff. That's pretty much it. Oh, no, there's one last thing, the mean value theorem. But we don't need to do all of these. Yeah, here's the boring thing here. Look at that. Whoop-de-doo. Yeah. Oh. Okay, so this is the formula, though, down at the bottom. The average value of the function, 1 over the range of values times the integral of the function. That's it. So it's pretty easy. So let's do, let's do these two, this one and this one. So the top two, because we still have to do the mean value theorem and we only have 10 minutes. So take a minute, set those up, even if you can't set them up first and then see how quickly you can do them. I'll get myself set up. Okay, screen's going to blink for just a sec. All right, let's get her done. Where are we? I don't have my randomizer up. I haven't been using it today. Okay. Well, we'll just do our best. So we need to know, maybe I'll just go around to here, do our best here. So bin P, in the front, what do we divide by, the first one? 20, very good. And that's 20 minus 0 is 20. Very good. Okay, next, we need limits. So we're back to Eli. Eli, what are the limits on this thing? Yeah, so 0 to 20 is good. And then I need an integrand. And so Hunter? Okay, Hunter, what's the integrand? What do I put in the integral? X cubed plus 20, is that what you said? Oh, yeah. Yeah, I thought I might have misheard. I have hearing loss because I'm old. Very nice. Okay, so now the rest of it, hopefully you can do. It is this easy. Average value. It's this easy. So this is 1 over 20 times x to the 4th over 4 plus 20x evaluated from 0 to 20. And so, okay, just a minute. This is going to be 1/4 times 20 to the 4th plus 20 squared, whatever that is. Give me a sec. 26. No, I can't do it in my head. So whatever that is, I'm not going to bother. Oh, I guess I could cancel one of the 20s, couldn't I? Let's not bother. You know how to do this. Easy. Punch it into your calculator. Let's set this up because we still have the mean value theorem. We're continuing on the reign of terror. So Thomas, what's the fraction? It's 1 over what for this second one? Yeah, so it's just pi over 2 minus 0, which is pi over 2. But I'll emphasize that by putting the 0 there. All right, Karen, what about the limits on this integral? What am I going to put there? Very nice, 0 to pi over 2. All right, we're doing great. And of course, we're just going to put this function in here. And we all know the oops. Oh, I'm mixing my letters, aren't I? Whatever. We all know the antiderivative of the cosine is sine. I just reciprocated the pi over 2, just if you're confused about that. And this is going to go from theta equals 0 to pi over 2. And then hopefully you all know that the sine of pi over 2 is 1, and the sine of 0 is 0. And so the final answer here is 2 over pi. Kind of interesting. The average value of sine or cosine is 2 over pi. All right, mean value theorem, last thing here, and then we're done. And that is that there is this rule, or this, that if you have a function that is continuous on a particular range of values, then it turns out that there exists a number in that range so that the function value at that number is equal to that range. Just to illustrate this, let's go back to the 2 over pi thing. It's easiest to see if you think of it as an actual function on a graph. So, and one of your questions on your homework actually asks you to do this. So here is the cosine, okay, there it is, between 0 and pi over 2. It goes up to 1. So that's what the cosine looks like. The average value is 2 over pi, which I'm going to put right about here. 2 over pi is a little less than 2/3. Now, here's what the mean value theorem says. It says that there will be some point on this curve that has that as its function value. We're going to call it C. And so what that means is that there is somewhere cosine of theta is equal to that number. And we want to know what the theta is sometimes because it's going to be important for certain problems, not for now, but for in the future. And so how would I find the angle that has a cosine of 2 over pi? What I would do is I would use on my calculator the inverse cosine, but I'm basically solving an equation. Inverse cosine of 2 over pi, as long as I'm in radians, because calculus is always done in radians, Looks like my answer is 0.880607. So that means that this here, that is 0.8807 is the point where this magic thing happens. Now, another interesting feature of this is if I draw this rectangle across here, it turns out that the area of that rectangle is exactly the same as the area of the curve. That's another interesting property. There's one problem, I think, on your homework that asks you to draw a rectangle. That's what it's referring to, is you found this value of C, you know where it is, you sketch a little diagram, and it's not obvious with my diagram because it's not a very good diagram, but it turns out that this rectangular area is exactly the same as the purple area. Okay, so hopefully that'll get you started on the homework. I'm pretty sure I'll be here tomorrow. If not, I will email you. But yeah. Just so you know, it's I'll be here hopefully just Wednesday and Friday. I don't know about as soon as I know, I will let you know so that you know what to do.